Hello everyone, myself Orgodip and welcome back to another Leetcode contest. This time it's the weekly contest 365. The contest is going to start. So let's start now. Cool, 4 problems. Okay, this time there are what happening? Minimum value of order triplet, right? Maximum value of an order triplet. You're given a 0 index integer and num. Return the maximum value over all triplets of indices such that num psi minus. I think we can just do it brute force, right? long in answer equal to 0. I think answer will be answer can be yes. Okay, so like for int I equal to 0, I less than n comma I plus plus, for int j equal to I j less than n comma j plus plus, for int k equal to j plus 1, k less than n comma k plus plus, okay, comma n equal to nums dot size, right? Okay, answer is long int current equal to nums I minus nums j current into equal to nums k, answer equal to max of answer comma current. I think the second part will have a much harder version with harder constraints for this problem because this is n cube. Yep. Okay, runtime error, let's see here. Okay, finish 77th 133.0. let's submit here and get is accepted. Cool, accepted. Okay, hurry, I haven't opened the problems also. Okay, you're given a 0 index integer and nums. Okay, so that it's the same problem. I think the constraints will be harder. Yep. So like I cannot do brute force here. Something in log n type things or O of n type things have to be done here. Okay, cool, let's think about it first. Just a second. What am cool, I think now count visited nodes in a undirected graph. This one problem 6. Okay, let's go over from easy to hard only. Okay, so like in this case what we can do is that nums k, right? Cool. So like if we fix the j, we are we good at anything if we fix the j? Yep. Okay, so like if we fix the j, we have to just pick the next greater element in the right. Okay, cool. And if we are not getting the next greater element, so if nums of I is less than nums of j, then obviously it will be less than 0 because nums of k will be greater than 0, so it doesn't matter. So it's just the problem of next greater and previous greater element, right? Okay, let's do it first. Int vector of LLA for LLN equal to nums dot size for auto and x in nums a dot pushback x, or something like this. It will be much faster. A of n for LL equal to 0, then comma plus plus a of I equal to nums of I stack of LL st for ll I equal to 0, I less than I1. Okay, while not of st. Okay, so like, okay, cool. Let me think of this 1 second, how to do the next greater and previous greater. Now let us small element comes. So this element. So now if any smaller element comes, cool. If any element comes, just keep on removing until we have found a greater element, right? Dot empty and then a of st dot top greater than equal to, right? Greater than equal to a of I, right? Okay, greater than equals to or less than equal to is less than equal to, right? st dot pop if not of st dot empty. Okay, if not of st dot empty, okay, vector of ll previous n next n, right? Previous of I equal to -1 next one, right? Previous of st dot top st dot push I. Just have to do this thing in the backward manner. If not of st dot empty, st dot pop, just copy paste this thing, right? Okay, minus 0 comma I minus should be next of I, right? ll answer equal to 0 for ll I equal to 0, I less than n comma I plus plus. If next of I not equal to -1 and then previous of I not equal to -1, answer equal to max of answer comma a of next of I, okay, sorry, a of previous of I, right? A of next of I into a of previous of I minus a of I, and that is it. An answer. Let's check it for the sample test cases. Finished 42 under 40. Okay, so okay, it's wrong. Cool. Let's check for some simple test cases. Okay, so let's 0 to 4, right? 0. Okay, okay, shit. I don't need the maximum, previous maximum. Yeah, I just need the previous. Shit. I did mess up here. Shit. I don't need the previous max. I just need the maximum here. Shit. I messed up here. Previous of I equal to max of a of I comma I previous of I minus 1 else 0, and that's it. Equal to n minus 1 0. Shit. Next of I equal to max of a of I the I plus 1 less than n. Okay, next of I plus 1 else 0. Right. We don't need any stack here. Just let the shit thing there. Can't time up. It's cool. Can fix those things. Okay. Okay, okay, I equal to 1, I plus 1 less than n. Right. Okay, what did I mess up? Previous of n0, next of n0. Next of I plus 1 is 0. I think up till this part everything is okay. Let's check once. Compilation error. Okay. I'm messing up here, I know. Okay, in this part only I am messing up. I equals to 1, I plus 1 less than n, answer max of answer, comma, a of, acha, next of I plus, acha, got it. Next of I plus 1 into previous of I minus 1 minus a of I. Alright, now let's run code. Cool. I pretty messed up here. It would have been done in under 6 to 7 minutes. But it's okay, let's submit. Cool. Now this is the third problem, this is the fourth problem, right? Okay. Maximum size somewhere in an infinite array and count visited nodes and directed graph. I'm weak at graphs, so let's focus on the third problem only. You're given an 0 integer nums and an integer target. 0 indexed array infinite nums is generated by infinitely appending the elements of nums to itself. Got it? Return the length of the shortest subarray of the array infinite sums with a sum equal to target. If there is no such subarray, then minus 1. Got it. Cool. So like, okay, I think it's an interesting problem. So initially the okay, all positive or negative can be there. Yeah, all positive. Cool. So basically it's like if the array is, if the shortest subarray lies in the original array only, then it's easy to find. We will just keep a map. We'll first do a prefix sum and then keep a map storing the latest index in which that particular prefix sum has occurred, and that's it. In O of n or in O of n log n, since we are using map, we can get that shortest subarray if it's present in only one copy of this array nums. But let's say it's somewhere in the between, like 1 2 3 1 2 3 1 2 3. It starts from one subarray and ends at another subarray. Cool. Then also it's easy to find. Just add another copy of this subarray to this and computer answer. And the final part is that it starts at some subarray, ends at some another subarray, and in between there are also some subarrays. Okay, then how many such subarrays? Okay, cool. There's a data graph in nodes. Okay. This looks like a familiar problem, I don't know. Sure. So let's think about it later only. First solve this problem. Yep. Okay, so cool. So let's write down our observations. I'm not writing in the laptop since it's wastes a lot of time. Okay, so initial part is done. Now if there are two copies of that subarray, then also it's done. I will just make a function and just pass it those two array, and now if it's like somewhere in the between, right? So like how many copies will I consider, right? Okay, so like, okay, 3 4, right? 3 plus 1. Okay, so if infinite sums, okay, so like the if the sum of the whole subarray is less than, okay, so if the sum of the whole subarray is greater than, greater than, sorry, is what I say, greater than equal to target, is greater than target, then in that case is greater than equal to only target, then in that case the third case will not appear. But if the sum of the whole subarray is less than target, right, then in that case it will appear, obviously appear. Okay. So it's something like we have some, so basically I have this problem, x into sum, I don't know the value of x may be pretty high, plus some left, plus some x sum, plus some prefix of the original array, plus some suffix of the original array, which will lead to my answer of target, right? Cool. All right. Okay, so I have to fix some value of what I say, x sum. Okay, can I do binary search on this x value? Okay, can I do that? Because if larger values is not permitting me to do, I don't know, I'm not sure about that. Prefix sum, we can just fix any index of this prefix, so this prefix part becomes constant. So now we are left with x sum plus suffix equal to target, right? Okay, now we can, okay, got it. Now we can find all those suffixes. These suffixes can be pre-computed in O of n. You can now find all those suffixes which on subtraction from the target value have the mod sum equal to 0. I think that's it, but it's a little bit complicated according to me. Maybe I am messing up. Yeah, I think I'm messing up, but let's mess up. Cool. The sum can be huge, so let's do long int only. Let's not focus that much. Define will be pushed back, right? Del equal to 0. Okay. lln equal to nums dot size vector of lla for auto and for ll I equal to 0 I less than n comma I plus plus a of I equal to nums of I ll t equal to target, right? Now first case is that the subarray is present in the original array only, right? Cool. Like mp of 0 equal to minus 1. Plus equal to a of I. Okay. If mp dot find current ref minus t not equal to minus 1, answer equal to so like initialize the answer with some huge values, answer equal to infinity equal to 118 plus 5, that will be fine. Answer equal to minimum of answer comma answer equal to infinity, answer equal to minus 1, or return answer, that's it. Answer equal to minimum of answer comma cool. Okay, I minus mp of current ref minus t plus 1, that's it. Cool. So this is the first part we are done with. Cool. Now let's coming to the other case. The second case will be automatically handled by this only, right? Okay, so like it's not also that much. Yep. Cool. Vector of ll saf of n, right? Okay, so like there will be at most I think I've got it here. Saf of n, no, saf mod t. So, okay, just do it like this. Map of ll comma ll saf. I will explain it after this screencast because I don't have much time left now. If I'm able to solve this, and I think I will do this. Current saf plus equal to a of I saf mod t percentage t saf mod t percentage t. Okay, plus a of I current saf percentage equal to t if saf mod t dot find current saf equal to saf mod t dot end saf mod t of current saf equal to I. That's it, right? Cool. Now let's iterate all the prefixes. So now one of the prefixes can be 0 and one of the suffixes can also be 0, right? So t0 equal to, I'll look after this like what you can do with this. Yep, that's it. Like Okay, cool. I think this is cool. So like, I think this soft mode T, right? Okay. So now just look over all the prefixes we have got. Initially we have got the prefix value to be 0, right? Initial prefix value to be 0, which means that T minus suf should be modulo m, right? T minus suf. Okay. Ref 0 lel keyword equal to T word equal to T minus suf. Okay. So like like T modulo n. Okay. If suf mod T. Okay. Dot find T. Okay. So find. Okay, this shouldn't be suf. This should be T. This should be current actually. Sum equal to 0 for auto indexing A. I think I'm complicating this, but let's complicate. I think this is it. Suf mod dot find. Okay. T modulo sum equal to not equal to -1. Answer equal to minimum of answer comma. Okay, minimum of answer comma. This is T modulo sum, right? Okay, cool. So this I've got right. T modulo sum, so like, yeah, cool. That will get subtracted prefix 0 by sum, right? LL times equal to T minus suf mod T. Okay, I'm messing up here. But it should be of I plus 1 less than n. Sum of I plus 1 is 0. Cool. Alright. T minus suf mod minus suf mod T. Okay. T percentage sum not equals to np dot end, right? Suf mod T dot end, right? T percentage sum T minus suf mod T percentage sum by sum. Answer equal to minimum of answer comma times plus n minus suf mod T percentage sum. Right, I think this is cool. I think. Okay, this should be n or n minus 1. This should be n minus 1, right? Some cases will be right. Yeah, right. Cool. Yep. cool. Now for ll I equal to 0, I less than n comma I plus plus, current equal to 0, current plus equal to a of I. So now this is ll required equal to t minus pref, right? T minus pref, right? Now so just the same narrative here, just the t becomes changed, right? If sub mod of t, okay, required percentage sum not equal to sub mod t, okay, so you can do something like that. If not of required percentage sum, right? This can also can happen, right? Required percentage sum well times equal to required by sum is equal to minimum of answer comma I plus 1 plus times कंटिन्यू. बट अगर ये नहीं हो रहा है, ये अगर हो रहा है तो अच्छी बात है. एंड दिस कैन ऑल्सो बी डन समथिंग लाइक दिस. रिक्वायर्ड परसेंटेज सम equal by sum, this is plus I plus 1, I think. It's a pretty complex code here. To debug it, I have to do a lot of strength. T minus pref minus current 1 4 minus 1. Okay, in the first case 1 2 3, right? Cool. So what is the problem here? Okay, 1 2 3 5, this means like, okay, see out answer here. Out 3 here answer. Cool. 1 2 3, right? Current pref plus equal to this. So this should not be t minus current pref minus x equal to t. अच्छा ठीक है. See out current pref minus t slash n. Current pref minus t minus 4, right? The first case it should be 1 minus 5 minus 4. Okay, so like 5 minus, okay, 1, right? And this one case will be there, right? See out mp of current pref minus t slash n, right? P of current pref minus 3 0, right? 0. Oh, okay, this plus 1 shouldn't be there, right? This plus 1 shouldn't be there. Yep, it's just upper minus lower, that's it. This case is done. Now t percentage sum pref 0, so like sum must be there. Okay, sub mod t, I'm doing some set here. Current sub plus equal to f, I can say it's cool. Dot end. Cool. T percentage sum. This is times into n, this should be right. Times into n should be times into n, right? I think this problem is not solved still, so right, cool. Okay, so like here sub mod dot t dot find t percentage sum So t percentage sum, what is t here? Percentage sum 5 not equal to soft mod t dot end, right? Cout times lesson times 0, right? Times 0 t minus, okay, cout soft mod t percentage sum. Pretty much complicating here, I know, but let's not go ranking. Cool. T percentage sum, right? T percentage sum, okay. T percentage sum, it happens in this case, right? In the case of, okay, it happens in the case of, in the index 1, right? So 0 1, okay. So like suffix of 5, right? Suffix of 5 happens in this gate. Cool. Times is 0 times into n plus n minus 1 cool, n minus 1 cool minus soft mod t. Okay, this should be n, right? Plus n minus soft mod t, right? This is cool. Plus n number t% sum plus I plus 1. That's it here. 2 is the answer here, right? 2 minus 1. 2 3 minus 1, right? So this case I have to debug again. 2 3 3, right? Yesterday out here is 3. It's not coming here. Okay, let's remove this. Okay, so 3. Okay, so like it's not coming here, right? Cout answer up till this point is 3. How did it come to be 3? Okay, so like here I think it should be 3 4, right? 2 3 4 2 3 2 3 4, right? Full 2 3 4, right? Full 3 here. Now required equal to t minus current, right? Cout required equal to required lesson required 3. First case required is 3, right? And of required percentage sum, no sum, I think not. So required t minus current pool. If soft mod t required percentage sum 3% sum, right? 3% sum. Cout soft mod t 3% sum lesson. Check it here only. 4, right? 4 0 1 2 3 4. Okay, cool. Required cool. Times is this thing t. Okay, so this should be t, I think. Time should be required minus soft mod t percentage sum. I think, right? I'm not sure about the code here. There might be bugs and all, but let's check once. This time equal by sum I plus 1 plus times into n. hmm. Required minus sophomore t cool required minus sophomore t required percentage sum by sum sum. This is times into n cool plus n minus sophomore t required percentage sum cool plus I plus 1. Okay, this is correct now. 2 minus 1, right? Let's submit it and hope it gets accepted. It took a lot of time here actually. Yep, a lot of time, bro. Messed up here. But still, fourth roll is not done by a lot of people. So let's try to get the fourth one pretty fast. I think there might be a pretty easier solution to the third problem. Directed graph consists of n nodes and n directed edges. Or given a 0 understood edges, for edges I indicate that there is an edge from node I to node edges I. You start from node X and keep visiting other nodes through edges until you reach a node that you have already visited before in this same process. Right. Number of different nodes that will visit if you perform the process starting from node I. Sure. Node from edge from node I to node edges I, right? Okay. So like from every node there is only one edge, right? From every node there is only one outgoing edge. Okay. Edges I not equal to I, cool. From node I, okay, got it. So from every node there is one outgoing node and edges of I not equal to I, so like there is no self loops and all, right? Do it first. So like we have this one outgoing node, then this one, every node has an outgoing node, like, so let's think of it something like that. Cool. You can start from a node X and keep visiting other nodes through edges until you reach a node that you've already visited before. Can it be done using DP? So like I start from, so like there will be cycles type thing, right? So like in this case, let's say I start from the node 3. From 3 I reached 4. So like in the meanwhile I will also try to update the DP value of 4 also. Like I will do some kind of a DFS call. From 3 I reached 4, 4, 0, from 1, 2, 3, right? Since I have reached it back, I think it's easy. Like why so less submissions? Or I think it's easy, I think, or not easy. 0, 1, 2, 0. For 3 it should be 1, 2, 3, 4. For 0 it should be 0, 1, 2. Okay, it's not that easy. Not that easy. Number of different nodes visited before reaching a particular node for this. Recording, right? Okay, it's not there, let's think out it only. start from node X and keep visiting other nodes through edges until you reach a node that you have already visited before on this same process, right? Cool. Hmm. So like there will be at least there will be only one cycle, right? Can there be more than one cycle? No, I don't think so, because a cycle, if a cycle, then it will consume n nodes, right? Three. If it's like, if there's a cycle, then there will be 3 nodes, right? No, it cannot be 3 nodes. No, there can be another cycle, right? 3 nodes. Okay, but can it be something like this? Like if it comes from this node to this node. 1, 2, 3. 1, 2, 3, 4. This is a valid graph. It's okay. One, two, three, four, 5, 6, 7. 1, 2, 3, 4, 5, 6. So will all cycles be disjoint cycles? That's what the claim I am trying to do. I think all cycles will be disjoint cycles. Otherwise, it's not possible to to have exactly n directed edges. That's what I am claiming here. Is my claim right? Let's check with some other samples. 1, 2, 3, 4, 5, 6, 7. 1, 2, 3, 4, 5, 6, 7, 8. 1, 2, 3, 4, 4, 1, 2, 3, 2, 3, 4. Yep. Then otherwise it will take one extra edge. So my claim is that all cycles are independent disjoint. So then it becomes pretty easy, right? Okay, no, not pretty easy. Okay, it becomes pretty easy. How it becomes pretty easy? Like, just a second. Not pretty easy. So like there can be at most one disjoint cycle, but there can be nodes attached to that one cycle, right? Some paths attached to that one cycle, right? Right. Let's say that I start from, let's say that I start my okay, let's say that I start from a node, and after some iterations I am back to that particular node again. Then it's a clear case of a cycle. For every visited node in that cycle, I will just add the length of the cycle as the answer, like here for this cycle or for this cycle, right? But if that node is, but let's say that if I start from a node and I reach some, and I ended up visiting some other node more than once, right? So like it's the case of this case, right? If I start from 3, reached 2, reached 1, reached 2, sorry, reached 0, reached 1, reached 2, and then reached 0. So like I visited the node 0 2 times. Okay, cool. So in that case, what I will do is that, and also we can mark these things like which nodes are part of cycle and not, and also mark their lengths. Cool. So like in this case, my answer will be the length of the cycle plus the distance between node 3 and node 0, which can be easily computed like in some type. So it's a, I think that's it, I think, but we have to be careful about the implementation part. ages.length, yeah, and n equal to ages.size. Cool. Vector of pool visited of n, right? Okay, visited, not like answer of n. Vector of int, okay, answer of n, return answer, and also can I just take a boolean array, which means that is cycle, like if this particular node is a part of a cycle or not, right? Cool. And also I think there can be a, I don't think okay, so like we don't need any kind of a visited array and all. This answer and each cycle is sufficient, I think, for now. If answer of I, that means continue, right? Otherwise what we'll do is that while not of answer of I, okay, so like can I just keep a vector here, vector of, can I keep vector the map can be suffix, let's give a vector only, right? Sure, no, that's not like the thing. Okay, got it, I can do this way. Vector of llv while not of, okay, ll current equal to I. Current equal to node while not of answer of current and while not of answer of answer equal to current equal to node answer of current equal to, okay, cool. Current is not cool, while not of answer of current, okay, cool. And okay, so like I will just do -1 here, right? Lot of answer of current, okay, answer of current equal to -1, current equal to age of current, right? Also v dot pushback current. Cool, right? Now okay, if current equal to node, then all are part of cycle, all nodes in V, okay, lot of answer of current. If current equal to node, okay, what you can do is something like this. Okay, so like not equal to minus, okay, if current equal to node, then it's the some case else if okay, answer of current equal to -1, then it's some other case, else some other case, right? Cool. So So like in this case, just keep a counter also, visited count. Cool. Just visited count plus we will do here, visited count plus, right? Cool. So this case, let's first handle this case. Okay, for octo and x in v. Okay, answer of x equal to visited count. I think that's it. 1 2 3. Cool. That's it. Let's I think that's here. Else if answer of current equal to -1, then it means that some other node has been visited, right? Sure. Like we need to travel that array again and find that node. This one case is it, like do it. That's it. Else answer of node equal to, okay, else, okay, for octo and x in v. Okay, for LLI equal to v dot size -1 I 0, comma I minus answer of I equal to, okay, so like I have reached this node, like this one, right? So everything must be completed, right? Equal to answer of count equal to 0, pointer equal to 0, answer of I equal to answer of current, okay, pointer plus current plus 1, answer of current plus pointer, right? I think that's it. And else if, okay, everything is node here, don't take long and complicate things. Cool. And if answer of current equal to -1, this means that got it. So how to handle this case here? Okay, so for this case, find that node, starting from that node till the end, everything is a part of cycle, right? Then index equal to -1 for LLI equal to 0, I less than v dot size, comma I plus if v of I equal to current, index equal to I break, right? Cool. Now since now I've got that index, what to do is that, okay, for LLI equal to index I less, okay, LL cycle length equal to v dot size minus index 2 3 4 2, right? V dot size minus index I equal to index I less than v dot size, comma I plus answer of I equal to cycle length, and also for int I equal to index -1 I then equal to 0, comma I minus answer of I equal to answer of I plus 1 plus 1. That's it. Yep. I think this is it. Let's check for some test cases. Compilation error, age of current. So ages of current should be right. compilation error again. This one is not this line, right? Compilation error again. Line 28. 433 minus 1. Acha. 1 2 3 4 5 0 minus 1. Okay, so 1 2 0 0, right? For this case, let's check once. Okay, so like firstly I will start from node 0, right? Okay, so from node 0, for node 0 answer is coming to be 4, right? Which is wrong. Cout visited count node equal to node current equal to current /n. Visited count 3 node 0. Acha, equal to node equal to current equal to, right? Visited count is 3, cool. Node 0 current 0, cool. If current equal to node, right? Yep. Auto and x in v, answer of x equal to visited count, right? Cool. So like here, okay, for level 0 I'll assign for my plus cout answer of I /n. After each iteration let's check the status, right? Arey yaar, cool. Visited count 3 node 0 up, okay, 3330, right? 3330, cool. So 0 1 2 up, cool. Now the node is visited count equals to 1 node 3, okay. So for the node 3 visited count is node 3 current 0, right? Cool. Answer of current equal to -1. I think it's the second case. I equal to v dot size -1. Answer of I equal to answer of not what is current here, no current here. Answer of no current, right? Okay, answer of current plus pointer cout here, cout current equal to current. Acha, I found that's right, I think. Cool. Here current equal to 0, right? And answer of current is 3, right? 3. I equal to v dot size -1. Okay. So like here I have reached 3. From 3 I have reached 0, right? So up till 0 I will try to calculate it, right? Okay. So is 3 for auto and x in v, cout x, cout /n. What's happening here, bro? Current 3, so only 3 is there, right? Answer of 3 equal to answer of current and 0 3, right? Answer of 3 equal to okay, so not answer of v of I, right? Sorry, so v of I equal to answer of current plus pointer. I think that is right. 3 3 3 4, right? This is what is expected from here. Cool. 3 3 5 4. Let's just debug my code once so that we don't get any unnecessary penalties. Cool. the same output. Cool. This part is cool. Visited count plus plus and so current equal to -1. Just a parent, right? Current equal to node visited count. This answer of current equal to -1. Int index equal to -1. Finally got that index. Okay, cool. This is cool. Index with index -1. Answer of I equal to. Okay, this should not be answer of I, right? Answer of V of I, answer of V of I, answer of V of I plus 1. Answer of V of I equal to cycle length, and yep. And for the other nodes, answer of V of I equal to answer of V of I plus 1, right? Cool. Answer of V of I equal to answer of current plus pointer. Current plus pointer. Got it. This is correct, it seems. Submit here. Accepted. Cool. I think I solved all the problems without any penalty, but took a lot of time. Okay. Fourth problem, I think around 500-600 people. Around 500 will be my rank. I messed up in the third problem. Cool. Not bad, like without practicing I'm giving. Okay, let's go for the solutions real quick. Okay, array yaar, what's happening? My right click is not working here. Cool. So like here is my rank. It will be around 600 to 550. No. Okay, cool. We are done with the contest. So now let's move over to the solutions part. So for the first problem, it's just a simple brute force. You just iterate over all the possible triplets. Like you run 3 loops, and one loop from 0 to n-1, other from I plus 1, other from the next part. It's pretty intuitive, and just you will just calculate the maximum value over all possible triplets, and the value is this thing. So like you will just do a brute force and find this value and just update your answer and return answer. So first problem was pretty easy. Second problem was good, but I messed up here by I messed up here by what I say, like with some complicated thought. So the value of the triplet of indices, right? So like it's same as the first problem, only the difference is that the constants here are a pretty higher. So like as you can see from the constants, O of n or O of n log n is the only possible optimal solution here. Others will give time limit exceeded. Okay, so like here from this expression nums I minus nums j into nums k, what you can see is that let's say that we fix j, we fixed the index j. So the index I will be on the left hand side of j, and the index k will be on the right hand side of j. Now as you can see here, to maximize this value, what I need is that nums I should be as high as possible, and also nums k should be as high as possible, right? Cool. So like as you can guess from here, if we fix the index j, we need the maximum value from the index 0 up till the index j minus 1, and we need the maximum value from the index j plus 1 up till the index n minus 1 for getting the value of nums of k, right? So that's it. You can achieve this using some prefix max or suffix max kind of thing. So what I did is that this previous variable is storing the maximum value from the index 0 up till the index I. That is previous of I is storing that value, and next of I is storing the value, that the maximum value from the index I plus 1, from the index I up till the index n minus 1. So this is achieved using a prefix sum, previous of I, and uh, using a prefix max and a suffix max, and then you will just take the this value, like like if you fix the index I, the index I plus 1 till n minus 1, you want the maximum, and the index uh, 0 till I minus 1, you want the maximum. Those you can get from this next of I plus 1 and previous of I minus 1. That's it, and just return the answer. Be careful about long. Okay, so it's mentioned in the return type that you should return long only, so that's cool. So we are done with the second problem also. Let's move to the third problem here. I think I have pretty much overcomplicated the third problem here, so let's deal with it in the last. First, let's move to the fourth problem, because it was much more the solution to the fourth problem is much more simpler for me than the third problem. So like for the fourth problem, what you are given is that you are given an undirected graph having n nodes and also n directed edges, and also it is given that from every node there will be only one outgoing edge, such that that outgoing edge is not a self loop. Got it? So this is the most important condition here, that there will be only n nodes, only n edges, and also like there is no self loop. Okay, so like from this what you can conclude here is that this claim I have concluded is that all cycles are disjoint. What I mean by this is that, let's say that how will I draw, let's say that I have a node, I have a cycle like this in my graph, 1 2 3 4 then 1 again, right? So like 1 2 3 4 and then again 1. So like this has n nodes, 4 nodes and 4 edges. But now if you want to have another cycle starting from the node 4 itself, like what I'm saying is that from the node 4 you have the 5, then you have 6, then you again have 4. This is not a valid case of according to the given constraints of the input graph. Why? Let's see here, the number of nodes is 1 2 3 4 5 6. The number of nodes is 6, but the number of edges will be 1 extra, that is it should be 7 in this case, 1 2 3 4 5 6 7. Yep. So like to have at most, like I don't have a formal proof of this, but it's like it's just some kind of an intuition that this is what. And I also checked out on copy pen that with some other samples also, and this is the claim and which I got, and this is okay claim since it worked. Cool. So this is the case here. So like this case is not a valid option for our input graph. But what can be the case? Like from 4 you can have 5, okay, then you can have 6, then you can have again okay, again 5. This is also not a valid case, because as you can see here, in this case also the number of edges will be 1 more. So only valid case is that if there is a cycle, these nodes okay, so like these edges will only be what I say, like if there is a cycle, there cannot be any other cycle from any of its from any of the nodes present in that cycle. So that simplifies our problem a lot. Let's see how. So I think I can draw whiteboard, but I haven't opened anything. Cool. So like this is the case. So like so now how will you solve this problem? For the case, let's say that we will just traverse through each of the nodes, and if the value of that node hasn't been calculated yet, we will try to calculate the value of that node and also all of the nodes that are connected to it by some way. Let's say that, let me explain it through an okay, yes, let me explain it through an example. Let's say that I started from the node 2, right? Then from the node 2 I will move to node 0, node 1, then again node 2. Okay, so like all these nodes I will keep in some vector or array type, so that I uh, I can so that while calculating the answer for the node 2, I will also be able to calculate the answers for node 0 and 1 also, right? So now, since from the node uh, from which I have started, I have reached the same node again, so this is a clear cut cycle. So for each of the nodes 0, 1 and 2, the answer will be the length of the cycle only, uh, 3 in this case. 0, 1, 2, 3 nodes, it's a 3 node cycle. Cool. Now let's say that we started from the node 3. Cool. And none of these nodes has been visited yet. So we start from the node 3, we reached node 0, node 1, node 2, and then again node 0. So we started from node 3, but we ended at node 0, since node 0 has been visited more than once. So that means that that starting from node 0 there is a cycle, and the path and all the nodes in the path from node 3 to node 0, there can be another node also, some other nodes also. Those are just some outgoing edges, those are just some incoming edges. Like in this case 6, 5, 4, like there is a edge from node 6 to node 5, there is an edge from node 5 to node 4, and node 4 is a part of a whole cycle. So in that case, what we will do is that for the nodes 0, 1 and 2, we will update our answer as the length of the cycle, but for the nodes 3 but for all the nodes on the path between 3 and 0, we will update our answer as, like, let's say, like for the uh, node 3, in this case our answer will be the answer for node 0 plus 1. Let's say that there was another node 4 here, so the answer for node 4 will be the answer for node 3 plus 1 in this way. So that's pretty easy. And the last case which comes is that, let's say that we started from node 0 and we started from node 3 only, but node 0 has already been visited. Then in that case we will just do like we will just update our answer with the answer for node 0 plus the so like here it's the same case only, it's like the it's same as the it's same as the previous case, only the fact is that we don't have to compute the value of this cycle length, except it everything is same. So now let's move over the code once. Okay, I think this boolean of is cycle is not required. Yep, it's not, I haven't used it, so it was an extra loop. So like if the answer for this particular node has already been computed, we will not do anything, otherwise we will just keep moving forward. Like from this edge I will go to its child edge, and for every node there is only one child. There can be multiple parents of a node, but only one child. So I just moved forward and marked all those nodes which are being visited in this loop as -1. We will update this answer in some further steps. Cool. And also we keep uh, track of all the nodes visited in this v vector. Now if these are the this current node, that is the node at which we ended, since this node has been visited more than once, is my original node itself, then it's a clear cut part of a cycle and it's done. Now this is the case in which which we talked about here, like we haven't visited any of the nodes here and we started from the node 3. Yep. So like the here current will be 0. So firstly I will try to find the index of 0, like the node which has been visited more than once, and the cycle length will be the path starting from the index of that node 0 until the end. And after that, for all the nodes from index up till the end of the vector, answer will be cycle length, and for all the other nodes the answer will be just the answer of the next node plus 1. And in the third case, it's just like this case, like this, we started from this node but node 0 has already been visited. So for this case it's just the same thing. I have just used a pointer here also for better readability and all, so that's not a big deal. Yep, it's this part is same as this part only, but here since I don't have uh, current pushed into my vector, so that's why I did this silly thing which I could have avoided, but it's okay. Whew. So that's done for the fourth problem. Now let's move on to the third problem, in which I think I messed up. I think my rank will be around, okay, it's not updated yet, but I think it will be around 600, 550 to 600, not better than that. Cool. So in this problem we will be having an array, and that array, and we will be appending multiple copies of that array, like that copies of that array can go till infinity, like 1 2 3, then again 1 2 3, then again 1 2 3, things like that. Cool. So the first case is that if the original, our answer shortest sub array is present in the original array only, right? So in that case it is pretty easy, just do a prefix sum of the whole array and just keep a count of that and just keep the index at which this particular prefix sum occurred latest. This is what I have done here. This is a pretty standard problem. I think you guys must have solved this. I am not explaining how I am doing here, so that's it. Now the second case comes is that this type of case. Okay, so like explain it here. Like some, let's say that this is my array 1 2 1 2 3, and this is another copy of that array. I'm just writing it separate, but it's just only one single array, and my answer is something like this. And there can be multiple copies of this also, not just one copy. So like my answer is something like this. Yep. So my answer starts from some suffix of the original array. It covers some whole arrays in the path and ends at some prefix of the original array. This is the case which you need to consider, right? So my approach to this was that let's break up this into this part. Like, so let's say that sum is the sum of the values of the whole array. So sum into x, this x is the number of times I am including whole arrays in my solution, in my subarray. So in this case the value of x will be 2, since I am including two whole subarrays in my subarray, two whole arrays in my answer shortest subarray. So sum into x plus some prefix sum plus some suffix sum plus some prefix sum will give our answer t, or it is target, right? Cool. So what we can get is that sum into x equal to target minus prefix sum minus suffix sum, right? Cool. Now what I will do is that I will fix the prefix sum, like I will go to each one of those prefix sums. Okay, so like so then what happens is that this part is fixed, so let's call it sum into x equal to required, like that this target minus prefix sum, I am naming this variable as required minus suffix sum. Okay, so for sum to be, so for required minus suffix sum to be divisible by sum, both that is required required modulo sum should be equal to suffix sum modulo sum, right? Cool. So this is my point of getting the solution. So then what I did is that, what we can do is that we can just initially keep all of the possible suffix sums modulo sum in an array, and we will keep only the first value. For example, let's say that we get suffix sum modulo sum of 4 at index 5 and 4 again at index 3. Then we will store this suffix sum modulo sum in some map that this suffix sum modulo sum has occurred in the index 5, not 3. That is the first index in which it has occurred if we traverse the array from the right, from the back. Okay, and then so that, okay, and then for each one of the required modulo sum, since this part is fixed, okay, so like we are iterating over each one of the prefix sum, so that will be O of n, and inside that we have this part fixed. So and also we can get this suffix sum modulo sum from the map in which we have stored these values, and then just update our answer. I'm not getting into the code here since it is a pretty messy code, but my intuition and solution was this only. So like in this case my answer will be sum, okay, so like x obviously, and how to, okay, so like how to find this x, we can find this x by this thing required minus suff sum by sum. Cool. And since in this suff sum modulo sum map we will be storing only the index, and the suff sum at that particular index we will have already stored in some array. So this part we will get, and from that we will x, what is x? The number of times we are including whole copies of the original array in our shortest subarray answer. That's it. So so my answer will be x plus x into n plus prefix sum, that will be, let's say that we are at index I, then it will be I plus 1 plus the suffix sum length, so it's like n minus 1 minus the index in which the suffix sum occurred. Here is the case, here this is x into n plus n minus this thing plus I plus 1. This is just another case, like not another case, this is the case in which we are not consider any suffix we can get our answer from the prefix only. So here in this case you will not find this soft mode, this part thing. That's it. Like there might be some edge cases which will be handled here and here. I'm not going over that. So that's it for this contest. Hope you liked it. Let's check my final rank if it is available right now. Okay, or maybe I am having 1055 rank only, but I don't think so. Finish time, my finish time is 1:06, right? Yep. So I don't think it will be, I think it will be around 500 and all, right? Around 500 to 550, I think. 106, and I become slow also a little bit. What happens? 106, yeah. 336 is my rank right now, but okay, Chinese has also been included, so I think 336 will be my final rank, or around 400 to 450. That's it. So that's it. Hope you liked it. Thanks for watching this video. Bye.